Now the lastly we discuss three important functions and their graphs. Already I told you under the part D 5 marks each, we see that definite question on graphs. The two, when you considering which are the important graphs in the final examination, basically the two functions, and sometimes they may ask greatest integer function, identity function and polynomial function. 99% important only two. One is modulus and other one is Signum function. Modulus function and Signum function are totally important. You have to prepare. The next possibilities you can see identity function, greatest integer function, polynomial function under which f of x equal to x square. That already we have completed. Now today first I discuss all about the modulus function. Generally we use that modulus of 5 is also 5, modulus of minus 5 is also 5. This is the definition. Here you can see that this is possible that x is greater than 0 and this is x is less than 0, and how you see this. But here we have to follow one definition, that modulus of x is always x is greater than or equal to 0. This is minus x is less than 0. But here when you apply that 5 is greater than or equal to is 5 only. When you take it minus 5, if you take this minus of x is minus 5. So this is also again 5 only. Whenever this number is less than 0, we have to write a negative. X value is minus 5. Again it is plus 5. So this is the definition in case of modulus of a function. So here I am discussing that how we draw the graph of this modulus function. And here first you understand that what is the definition of modulus function. Already we have discussed other function, the function f of r to r defined by, look this, defined by model f of x is equal to modulus of x. It is a definition. F of r to r defined by f of x is equal to modulus of x. Then what is modulus of x? Here modulus of x is always x is greater than or equal to 0. Modulus of x is equal to minus x when x is less than 0. So try to understand what is the domain of this function. When you take the domain, all the values of x r to r, so that is why here we find the set of real numbers, and the range f of x plus x and minus x. So here you have to see that particularly when you go for taking the range, if you say, and always we find the positive values, and accordingly you can see that how we see that range is a set of non-negative real numbers, means that positive. That is why already I told you, modulus of 5 is also 5, modulus of minus 5 is also 5, so that there is no there we see negative, only maximum positive you can say, and 0 you can say, and not negative numbers. That is why here you have to see that modulus of x, here you see plus x when x is greater than or equal to 0, minus x when x is less than 0. This definition you have to follow it. According to this definition, and you can go for to draw the figure, and accordingly we can see the result here. And here you have to see that all x here that belongs to the real numbers. You see that real numbers, and here that is why here we can see that the domain of the function is set of real numbers. And basically you have to understand that when you see that non-negative, real non-negative means all positive including 0. Here also I can say 0 is neither positive or negative. When you go for excluding the negative numbers, we will get positive and 0, and that is to be considered in case of modulus of function. So set of non-negative real numbers means all positive and 0 it means. So once again I say that f of r to r defined by f of x is equal to modulus x, and modulus of x is equal to x is greater than or equal to 0, modulus of x is equal to minus x if x is less than 0. So now we have to draw the graph of the modulus of function here, and accordingly you have to go for it. So the question is, maybe asked question is like this: draw the graph of, graph of the function. Draw the graph of the function, what do you say, f of r to r, defined by what you say, f of x is equal to mod of x, where try to understand, and for all x belongs to r, where modulus of x is equal to x if x is greater than or equal to 0, and this is x, this is x, and what you say, x is less than 0. So now let us drop the graph of this function, graph of the modulus function. You try to understand the definition of the modulus. So now here we can see the result, that how you go for writing the graph here. So that I want to explain. First I have to tell you the how to prepare the tabular form this. Look this tabular form of this. First you say x and f of x, and accordingly you can see the result here. One thing you remember, how to draw the graph of the modulus function, and how many numbers of here we are taking, that is secondary part, and you have to go for all the real numbers. So 4, 3, 2, 1, 0, 1, 2, 3, 4, this number I am taking now. See this? These are the real numbers, and here you see minus 1, minus 2, minus 3, minus 4. Yes. According to the definition, you see that f of minus 4, this modulus of minus 4, it comes the plus 4. And what is this? Plus 3, 2, 1, 0, 1, 2, 3, 4. So no negative here. All are because you try to understand modulus of minus 4 is equal to minus of minus 4. It becomes plus. Why? Modulus of x is equal to minus x if x is less than 0. And this 4 is less than 0, you know. 4 is less than 0, that is why minus of x is minus 4. So it becomes positive. This point is to make it a clear understanding. So that is why here you see that minus 4 modulus is plus 4. And even if you see that definition, modulus, and now how to, you have to draw the graph of this that I am telling you. So now you see that plot the points. How many points? 1, 2, 3, 4, 5, 6, 7, 8, 9 points is to be taken. And A, B, C, D we have to start it. And then we draw the graph. And try to understand how minus 4 you become plus. Modulus of minus 4 is plus. Modulus of minus 3 is 3. Modulus of minus 2 is 2. Modulus of plus minus 1 is 1. And respectively that, using the definition of the modulus. Now suppose this point is A. What you say? Let A is minus 4 plus 4, and B is minus 3, 3, and C is minus 2, 2, and D is minus 1, 1, and O is 0, 0, and next what? A, B, C, D, next E is 1, 1, F is 2, 2, F, G is 3, 3, H is 4, 4. So these are the points. And let us see that how we see the result. Once again you make it clear how why modulus of minus 4 is plus, because that definition once again I write modulus of x is minus x. This is the definition when x is less than 0. Try to understand. X is what? X is here x is equal to minus 4 we are taking, and this minus 4 and minus x is what? Minus 4, and it becomes plus 4. So when x is greater than or equal to 0 and the value of f of x is x, when x is less than 0, the value of f of x is negative of the negative of f of x, and that is called value of x, negative of the value of x, negative of the value of x. So that is why it comes positive. Now how to draw the graph, that I am explaining here, and no doubt here that maximum is, and here you have to see 4. So I have to draw the graph here, and now I have to remove this because already we have plotted here. With this, how to draw the graph? This is totally under part D, 5 marks. So careful how to draw the graph. Scale you can take 5 units equal to 5 small division equal to 1 unit. This is x, x dash, and y dash 4 is it. Maximum is 4. Look this. 1, 2, 3, 4 means 1, 2, 3, 4. See 1, 2, 3, 4. Same distance you have to write. 1, 2, 3. So here you see that minus 3, minus 4. Look this. 1, 2, 3, 4. So up to this. Look this. Minus 1, minus 2, minus 3, minus 4. This is x dash. Look this. And similarly 4. We have to go for like this, same distance. 1, 2, 3. See, y is 4 also there. So it is not possible to set it here. 1, 2, 3, 4, it goes up. So that is why you have to go for smaller divisions, and accordingly you can see the result. So how you take the smaller, that I am explaining. In the graph sheet or in the notebook you have to judge it, which is possible. And how you see this result, and accordingly you have to see maximum is minus 1, 2, minus 3, and here you have to see that positive, y is no positive, y is always positive, negative is not possible. So y, when it is positive, you know, let us draw the graph like this, because negativity is not there, you know. So that is why you have to go for like this. First you understand how to draw the graph. This just bottom side I am telling you, know. Look this here, and accordingly you have to go for it, divisions, and plus 4, minus 4, and here you have to see that minus 4. Look this, same way, 1, 2, 3, 4. See, 1, 2, 3, 4. 1, 2, 3, 4. Next, 1, 2, 3, 4. So here -1, -2, -3, -4. And here the same distance 1, 2, 3, 4. 1, 2, 3, 4. And here you see this, and the same way -1. I mean, it's not necessary because no points in the negativity on the y-axis. Look this, -4 + 4. See here, -4 + 4. You have to look this, and here you see, and here it comes. This is A. A is -4 + 4. Next is -3, 3. See here, -3, 3. Here it comes. -3. It comes here. That is B. Next -2, 2. -2, 2. Here you see. Here you see this value is -2, 2. And next what? -1, 1. -1, 1. Here you see. And next is 0, 0. In the same way, 1, 1. You have to see 1, 1. Here it comes. Points C, D, and this is E. F is 2, 2. Here and here. So this is what is A, C, D, E, F. Next 3, 3. So here you have to see, and here it comes here. This A, B, C, D, E, F, G. And next what? 4, 4. 4, and here you see this 4, and here also you can see the result here, and this comes G, H. Now join the points, and here when you join the points, and you see how we get the graph. Look this, when you join like this with the scale, and here you see. So this is the graph. So this graph is try to understand f of x is equal to mod x. This is the graph of this function, and here you see that how you find the result, and that is why here you make it understanding how to draw the graph of this. And here you can see that this is the graph of the modulus of the function, and accordingly you can continue. So once again I say that f of r to r defined by f of x is equal to modulus x, where x belongs to r, and f of x is equal to mod of x is equal to plus x if x is less than or equal to 0, and minus x if x is less than 0. So this is the all about the modulus function. The question maximum times asked this question, modulus, how to draw this graph. So first define modulus and draw the graph. So this is the way how we can draw the graph of this. And one more important function that I have to discuss, that is called Signum function, you can say. So what is Signum function, that I want to explain first. Signum function means what? Signum function. Already we have discussed modulus function, but now we are discussing Signum function. Signum function means what? That we have to understand. Basically, when the function is defined, f of r to r defined by, look this Signum function defined by f of x is equal to, so three values we can say, 1, 0, minus 1. So the only three values you can see, 1, 0, minus 1. But here you have to see that when you get it, this value, and you can say this is x is greater than 0, this is x equal to 0, and this is x is less than 0. So when f of x is equal to 1, x is greater than 0, f of x is equal to 0, when x is equal to 0, f of x is equal to minus 1, when x is less than 0. So this is called what? Signum function, you can say. And particularly when you see this function, and accordingly you have to go for explaining that how to draw the graph of this function. First you see once again the definition. The function f of r to r defined by 1 x is greater than 0, 0 when x equal to 0, minus 1 when x equal to 0. Then you try to understand that R, all x belongs to R. Ultimately domain is equal to the set of real numbers. Then what is the range? Range means the values of f of x. The range is equal to which are value? 1, 0, minus 1. So you can see that minus 1, 0, 1. So this is the range, because no possibilities of other values in case of Signum function. Whereas x is set of real numbers, x belongs to R, and the range f of x is only possibilities 1, 0, minus 1. So this is the range, and this is also important to define and also to draw the function. And here I have to explain that how to draw this function, this Signum function. And what I write, question may be asked like this: draw the graph of, graph of the function. Draw the graph of the function f of r to r defined by, look this, defined by f of x is equal to 3 values, 1, 0, minus 1. This is x is greater than 0, this is x is equal to 0, this is x is less than 0, and domain is R, and the range is, already I told you, minus 1, 0, 1. So this is the case, but now I have to explain that how to draw the graph. Just taking the scale on the graph sheet, how to go for this graph that I am explaining here. So now you have to see that the result. Tabular column first. I want to tell you the tabular column of this. Look this. First is x, f of x. And here I want to tell 0, 1, 2. And here minus 1, minus 2. Only these values you take. That is more than enough. So try to understand that what is the case here. Minus 2, minus 1, 0. Here we have taken that. Even if you see that more values you can also take. More values means you take it this here minus 3, and here you have to take plus 3. That also possibility is there. So now we have to define the values of all these. Minus 3 is how much, and minus 2 is how much, and minus 1 is how much, 0 is how. So now I have to fill up this bracket. Look there. X is equal to minus 3, f of x is equal to how much? X is equal to minus 3, is there f of x is equal to f of x is equal to 2. See, this minus 3 is less than 0 or greater than 0? Less than 0. Then what is the value? Minus 1 you have got. See, minus 1 you have got. If x is less than 0, you have to get minus 1. And minus 2, less than 0 or greater than 0? Less than 0. So this is also minus 1. And this is also minus 1. And when x is equal to 0, ultimately answer is 0. And x is greater than 0, here 1, greater than 0, 1, 1. Look this, how the tabular column we have prepared according to definition of Signum function. Look this, when x is less than 0, minus 1, greater than 0, plus 1, equal to 0. This is the definition of the Signum function. Accordingly, we have prepared the table. I hope minus 3, minus 1, how you have got? This is less than 0, it should be minus 1. Less than 0, minus 1. Less than 0, minus 1. Equal to 0, 0. Greater than 0, plus 1. Greater than 0, plus 1. Greater than 0, plus 1. Even if you take 4, 1. However, that is so on. Now, how to draw the graph of this? Taking the scale here also. 5 small divisions is equal. First you put the point here. A minus 3 minus 1, B minus 2 minus 1, C minus 1 1, and O 0 0. Next we see D, 1 1, E 2 1, and we see E, F 3 1. So here you have got the value. These points should be plotted. See how to plot this. Already I told you x-axis and y-axis here, and here the bigger number is -3 3. So no problem here. So you have to go for 1 2 3, 1 2 3, 1 2 3, and here also 1 2 3. Here you see -1 -2 -3, and here you go for taking the up value. See this 1 2, of course 1 2, here you see that 1 2, and here you see this -1, and here is -2. Now plot the points accordingly. We have already prepared. -3 -1, -3 -1. See, -3 is here and -1 is here. -3 -1 is here. This is nothing but A. And B, -2 -1, -2 -1 here. This is B. Next, -1 -1. Here you see -1. See, here I have written wrongly. -1 -1, because less than 0, -1. -1 -1. I got the point here. What is the mistake? When this value is less than 0, it should be -1. Greater than 0, +1. 0 0. So -1 -1. So here you have to see this value, and here you see that C -1, and try to understand this value. But here when you see this particularly -2, when you are taking that, and y is +2, and all these possibilities when you are taking, you have to go for plot the points. Once again, A is -3 -1, -3 you have taken here. It is not -3, -1 is below is there. So you cannot take like this. What I say, -3 -1. Here you see this -3 -1 is here, and the next -2 -1, and this is here. This is what I say, this is A, this is B, and next one is what, -1 -1, and is here, and what you say, this is C, and here you have to see that when x is equal to 0 and y equal to this also 0, and now you go for taking one point is here. Okay, limit now 1 1 1 1 means here only you have to see this is 1 1, and here 1 1, and 2 1, here also you have to see 2 1, and the value is 1 1 is D, and this is E, and F is 3 1, and here you see these are the points. Now when you go for taking these results, and you have to go for how to plot the points here. So now you join this, and accordingly you can find out the graph of this Signum function. Look this, when you draw it, it reaches to -1, and here you see it reaches to +1. This is the graph, and try to understand here. This is y is -1, and here y is +1, and you know this is y dash, and x, here you see x dash. So this is what we call the Signum function. Draw the graph of the Signum function, and now you can go for taking any values like that. The graph must be the same. And one more thing is that here when you go for taking that result, and accordingly we can see the graph lengthy, bigger one, you can see that. But one more point I want to tell you here, this case how it is there. Additional part I am giving this. See, f of x is equal to, you are told, once again I write, -1 x is less than 0, and first one x is greater than 0, 0 x is equal to 0, minus 1 x is less than 0. But when you go for taking these signum functions accordingly, this you have to write this f of x is, you can write modulus of x is equal to x. So modulus of x is equal to x, and here it comes 1, because modulus of x is x, and here you see that x by x, it comes 1 when x is not equal to 0. When x is not equal to 0, you will get it 1. And suppose if I say this is equal to 0, if x is equal to 0, now here you have to see that how this is defined. Modulus of x, that is divided by x, and that should be x is equal to 0. And when you see that result, when x is equal to 0, then ultimately this is 0, you can say. And it is defined only that, see, the two conditions can be taken. X cannot be 0, here x is equal to 0. And here we will see that possibilities of plus 1 and minus 1. So this is it is exactly the same as this, x is equal to 0, and here you see that x is lesser when x is not equal to 0. And when you see this result, and now you can go for defining that x is negative, smaller, you will get minus, and bigger you will get it minus 1, plus 1, we will find here, that time x is not equal to 0. So you see that this signum function, you have to define very perfectly that it is like this, 1, 0, minus 1, x is greater than 0, x is equal to 0, x is less than 0, and that graph we have drawn here. So this is all about the, and here I already have told you what is the domain R, what is the range. Range is only these values, minus 1, 0, 1, minus 1, 0, 1 is the range, minus 1, 0, 1 is the set, that is called the range of the signum function, you can say. Now finally one more function we are discussing, that is called greatest integer function, and how you go for a greatest integer function, and that I can explain here. First you have to understand what do you mean by greatest integer function. That is the last one, you have to see this greatest integer function. Look, this greatest integer function. So in shortcut we can see that if you take that x is an integer and x belongs to R, any real number, so the greatest integer is means not x, greatest integer means not exceeding that one. So here we have to see that when you go for the value x, if x belongs to R, and this is the greatest integer means not exceeding R. Not exceeding R means not greater than, not exceeding this value of, when you call this greatest integer function, value of x is not exceeding x. When you call this function, you see f of x is equal to x, and here you have to understand that when you are defining this, and ultimately you can go for writing the greatest integer function, and what are the possibilities that I am discussing here. So integer function is not, greatest integer means not exceeding x. Not exceeding x means it is lesser or equal to x. Greatest integer function is denoted by the symbol like this. Look here. This is a symbol for greatest integer function. What do you mean by this? This is that it is the value of x not exceeding x. It means to say equal to x or less than x. Greatest integer function is lesser or equal to x, and that is denoted by the symbol. When I write this, you have to use the word greatest integer you have to use. And how we define that I am going to explain here. So that function, when you are defining like others, the definition of greatest integer function, how you are defining the function, look this, the function f of r to r defined by, look this, defined by f of x is equal to this box x. And what is this box x? It is lesser or equal to x, not exceeding x. And now you have to see this, what is the domain and what is the range of this function you have to tell. So x belongs to R, and domain you can see that basically that set of real numbers, and similarly range of means what we get it, range, that integer only we get it, that integer. So here domain is R, and this f of x is always an integer, or you can say set of integers. You see, set of integers. What set? If you go for taking any real number, its greatest integer we have to write, means lesser than that, lesser or equal to that. So using this definition, and now we have to draw the graph of this greatest integer function. Greatest integer function is denoted by this box x, and that value is always lesser or equal to x. It means to say value of x not exceeding x, and accordingly you can draw the graph of this. Suppose if you go for taking any real number, I'm explaining some results here, and accordingly you have to plot the graphs. So this real number is, look this, some real numbers I take, and what is its greatest integer, you have to tell the results. So 2.01 is there. So what is this? 2.0 is not an integer. 2.01 is not an integer. Then what is the greatest integer? This is equal to what? Similarly, 2-3 examples I am writing, and I explain how we have to write the results here. Suppose if I take 2.9 is what? And here you make it clear understanding. Based on that we have to work out the problems later on. And when you see that next is 2.99 I write. 2.99 is, see 2.01, 2.9, 2.99, and also you can see that particularly minus 1.3, minus 1.3, what is its value? Minus 1.3, what is its greatest integer? And one more, you can see that when you go for taking greatest integer, if you take greatest integer 3 if you take, and what is the greatest integer function? So in order to write the values of these greatest integer functions and make it understanding that real number line here, see this is 0, 1, 2, 3, 4, 1, 2, 3, 4, and minus 1, minus 2, minus 3, and minus 4. You just for reference you have to take it. This is, with the help of this you can write the greatest integer function. Going through that real number line, you have to write 2.0 is format. So the greatest integer is not exceeding this, but what? Lesser or equal to it. So when you go for 2.01, and you cannot take more than 2. Which is less integer is what? 2 only. 2.01, where it is 2 point here, and lesser is what? Lesser or equal, that is nothing but 2. And 2.01 is non-integer 2, so that answer is 2. And here 2.9, and here the is not an integer, and lesser is what? That is 2. And here is also 2. 1.3, where it comes, you see 1.3. See 1.3, and 1.3, it is lesser is what? 1.3 is what? 1.3 is again here minus 1.3 here, minus 1.3 here, look this, minus, this is minus 1, and minus 2, minus 1 here, and minus that lesser is minus 1 you have to see. This value is minus 1. And 3 integer also, that is integer, 3 can be written as 3 only. So you have to go for minus 1.3 here. You have to make it clear minus 1.3 where it comes. Minus 1.3. See 1.3 here. 1.3 is the greatest. Minus 1 by minus 1 is greater than minus 2. So minus 1.3 in between this. And here which is the least one? Minus 1 is greater and least integer is what? Minus 2. So that this value is minus 2. Make it clear understanding. Minus 1.3 in between minus 1 and minus 2. And which is the least one? Least one is minus 2. You have to take lesser or equal, not greater. If I take that minus 1 and again excluding that value. So minus 1.3, that value is, you have to take it as minus 2. And now you see that how to draw the graph of this. And particularly, I want to explain this idea in another fashion, another way, how we write this greatest integer. And later on, I am explaining the values of this. So when you go for taking this function, what functions I have told you? F of x is equal to greatest integer function. And here, that value is not greater, it is lesser or equal to x. That is the definition. Suppose if I write f of x is equal to greatest integer function. So f of x equal to possibilities I am writing here for the reference here. Suppose if I take that values, which are the possibilities of the values. See, when you take that x is equal to 0, and here we see that this value 0 means in which interval it comes here, you have to tell that it is 0 and 1. So when you take it 0 and 1, see, lesser than 1 and maybe equal to. So why write 0, 1? Why write plus? This is closed, this is open. Why write open? Some authors may write like this. See, either you write like this or you open it. This is means it is not equal to 1. It is lesser than 1. And why you are writing? It may be equal to 0. So that is why you can understand that you may write for reference, and when x is here you see, and that greatest integer function is like this. So x is, look this, when x belongs to what? 0, 1, and ultimately it is 0. Why? Because when the x is in between 0 and 1, it should be 0 only. Like that, suppose if I say that x belongs to, the next interval I am giving here, that 1, 2 I write. 1, 2. It should be like this. And tell me what is the value? And here x belongs to 1, greatest is this, and x belongs to this, and the least one are equal, and it is nothing but 1. So here when x belongs to 1, 2, it should be taken. And the last I take that when x belongs to, see that 2, 3 I write. And ultimately we have to see what is the value of this. This is 2. And lesser than or equal. And similarly, when you go for that value in the negative side I am talking here, when x belongs to minus 1 and 0. And minus 1 and 0 if you write, then what is the value? The least is minus 1 you have to tell. And similarly you can go for, if you want to write one more, that when x belongs to, see, minus 2 and the other one is minus 1. This is open, minus 2, minus 1. Then what is the value of this? Is minus 2. So here you understand that how we find the greatest integer. See, these are open, these are closed, and open means strictly less. This is that may be equal or lesser. So this is the graph we use now, and this is the case, this is the definition of, you try to understand modulus of x, this is modulus of x. This box X, and this box X is nothing but what? Greatest integer function, and these are the possibilities. Now I am going to explain how to draw the graph of this modulus function, and accordingly you can go for it. So here also I say that numbers and to draw the results. So first I tell you that maximum and minimum values you can go for it, and accordingly you can see only these numbers I am taking here. So what numbers you have to see? That -2, -1 and -1 and 1, and accordingly you can see the results. So when you write the graph, this greatest integer function only with 4 values, you can see this greatest integer, and see that important part here. This is origin, only 4 you have to see. 1, 2, 3, 4. What you say? 1, 2, 3, 4. The same distance. 1, 2, 3, 4. -1, -2, -3, -4. And here also you can see 1, 2, 3, 4. 1, 2, 3, 4. And the same way is -1, 2, 3. You see this -1, -2. Only I have to take 3. It's more than enough. Now how to plot these points I am telling you now. This is very important part that I have to discuss here. First you see that the values, accordingly you can draw the x-axis and y-axis, you can go for it. So this is x dash and x, y, y dash. So any interval if you take, and accordingly you can start with this. Suppose if I take that 1 to 2, if I take that 1 to 2, so this interval I take 1 to 2. Where it comes 1 to 2? 1 to 2 is here, and here you have to see that 1 to 2 value is 1. So here you have to see that value is 1, you have to get it. 1 to 2 I have to write. So this 1 to 2, here value is 1. So this is 1 to 2. And here you see that it is 1 to 2 open. Open means it should be that empty circle, and this closed means like this. It should be open and this should be closed. So this is the graph 1 to 2. Suppose if you take 2 to 3, 2 to 3 is here, is it not? 2 to 3 value is how much? 2. 2 to 3. See this you can go for is over. Next 2 to 3. 2 to 3. 2, 3. So 2 to 3 is 2 and lesser, and it should be open and it should be closed, and this is the graph of this 2 to 3. So 1 to 2 is over, 2 to 3 is over. Next 0 to 1, 0 to 1, 0 to 1 is 0. So this is darkness, and you can tell that this, and here that answer, this is 0 to 1. Next what? -1, 0, -1, 0, -1, 0 value is what? -1. That -1, 0 where it is? -1. -1 is here. So that here you have to go for result. See, and result is -1. -1 here you go for taking this result, and -1, 0, and what is the answer here? -1. And try to understand that how you get it the result, and accordingly you can write it. So -1, 0, see -1, 0 here, this is open, -0 is open, and here you have to see that -1. And look here, when you go for taking this value, and 0, if when you take x is equal to 0, it should be open and this should be closed, because answer is what you say, -1, 0, answer is -1. And -2, -1 you see, -2, -1, -2, -1, you go for -2, -1 is -2, -2, -1 you have to go for, this is -2, -1, So here you have to go for minus 2 minus 1 value is how much? Minus 2, and it should be dark, it should be open. So here like that you can draw the graph of only 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So like that you can go for any number of that intervals you can take. And where, see, once again, if I draw like this, this is not included in the graph. When I do like this, it is included. It is included in darkness, and empty is not included. So here, but in the notes I have written open bracket, it is like this. If you like this means what? It is open. This we can write. And you see, this is same as like this, one and the same. You, instead of writing open, you may write open. This also permitted and this also permitted. So this is all about the greatest integer function, you can say. And in the examination, the possibilities we can see modulus and signum function. And at last, one more, the function I am defining without a graph. That is not in the text, but even some problems you may see, and that is why I am explaining. The last one is a linear function. And a linear function means what? Look this, linear function. Linear function is nothing but the function f of r to r defined by, what do you say? Defined by f of x is equal to ax plus b. Ax plus b, where a and b are constant, and this is called a linear function, you can say. Sometimes some authors may be taken as f of x is equal to mx plus c, some authors say. This is also linear function, and try to understand that a is also constant, b is, and here m is also constant, c is also constant. What is the definition of the linear function? If r to r defined by f of x is equal to ax plus b, then it is called a linear function. And sometimes you can see the problems, and accordingly you can write it. So linear function means what? Ax plus b. A and b are what? Constant. So this is the types of functions so far we have discussed. And once again and finally I tell you before taking the next part that important is modulus and signum and greatest integer. And very less important means identity, and in one is polynomial, that is f of x is equal to x square. See, I am giving you the guarantee, out of 5, 1 must be definite for 5 marks, out of which only important is these two, modulus and signum. And rare case they may ask greatest, rare case they may ask identity, rare case they may ask f equal to x square, is a polynomial. Rest other functions are not asking for 5 marks in under part D. So which are possibilities 5 marks question? In this case, modulus and signum 99%. Less important means greatest, identity and polynomial. And other functions they never ask. Why they never ask? Because 5 marks cannot be allotted for those functions. So this is all about the types of the functions and graphs. And finally I have to discuss that operations on functions, and that I want to tell you the operations, how to operate, and accordingly I have to tell you the functions. There are 5 operations that we can see. Suppose x belongs to R, you take it any x that belongs to the set of real numbers, and here first one is sum of 2 real numbers. The first one is sum of 2 real numbers. Try to very simple but important. Sum of two real numbers. How we operate the functions, this sum that I am going to ask here. So the two functions we are taking, one is, you see, f of, here you have to go for that is you can take it any that is set of real number to real number. F is one function that can be taken here, and basically when you see that one set you can take it accordingly, you can take it, and the set of real. Suppose if you take one set in which you can see sum f of x to r one function, and another one is g of x to r is another function. X is any set that you can take. So f of x to r and g of x to r, and see f plus g of x is equal to what? This is defined by, see, define. This is one function, this is another function. F plus g of x, how you define this, and that I am going to explain directly here. So accordingly, this when you go for taking this result f plus g, x is there, x is there. So here also we have to tell that x is there. So this is one, this is, and this is there some f of x to r, g of x to r, f plus g x to r. So how you define this, that I am going to explain now. So now you see that when you are defining this, and what is the definition? So here we define that f plus g of x is equal to f of x and g of x. Once again, f of x to r, g of x to r, two functions. Then you see their sum f plus g of x to r define, that is f plus g of x is equal to f of x plus g of x, that you can say, and accordingly you can go for writing the result here, and try to understand for all this x belongs to r. This x belongs to r. Only one is important. Rest I define like this. Once again, sum of two real numbers, sum of two real numbers. So here sum of the two real numbers, sum of two real functions also you can consider, and accordingly you have to see that, and because functions may be taken as a sum, and here sum of two functions, you say, sum of two functions. This is first and this is second, and their sum you have taken. Now I go for immediately to define other. Sum of two real functions you have defined, f of x to r, g of x to r, then f plus g of x to r defined, f plus g of x equal to f of x plus g of x for all x belongs to r. Next, if you go for that difference, if you take difference of two functions, then what you write? Minus. What you write here? Minus. What we write here? Minus. Yes, for all x belongs to r. This is a difference of two functions that we can see that. And when you see that different, now you see that product, you see that. Product, you see, product of two real functions, x to r, g x to, then here you have to write f into g, define, and here f into z, and here also you see that f is into z. This is for all x belongs to r. And similarly, when you go for that division, quotient that we are defining, quotient of what? Two functions. Quotient. Quotient means f r, and here we write f by z, defined by here f by z. This is equal to f of x divided by g of x. Only condition is that g of x is not equal to 0. So how many you have taken? Sum of two real functions, difference of two real functions, product of two real functions, quotient of two real functions, and finally one more. In general, we can see that particularly scalar multiplication of a function. What do you say? Scalar multiplication of a scalar multiplication of a function. So this also we take it under this operation. What is this? Because already we have told you that is f of x to r is the function, and x is any set that can be taken, and accordingly you have to tell that x to r, and here you take it one scalar here, where you see now let alpha is a scalar. Scalar means any constant you can take. When you take that function x to r, when you are going to write that a scalar here, and now you have to see that how you define alpha f of what do you say, x to r, defined by, look this, defined by, see that this is alpha of f of x. So you can write that alpha of f of x is equal to. So how you have defined some difference quotient like that, you can define this alpha of f of x is equal to, you write it directly that scalar quantity is to be taken as alpha into f of x for all x belongs to R. So this is called scalar multiplication of a function. Once again, sum of two real functions, difference of two real functions, product of two real functions, quotient of two real functions, and finally scalar multiplication of a function, and here we have taken. These are the operations on functions. So in the next class, and we see that problems finally, and that is the last class. One more class I continue, that tomorrow, that is the end of this chapter functions and real function, and even I am sending that today the examples, and after that I am giving the questions answers with part A and part B, part C, part D. Here this chapter is containing part A is 1, part B is 2, part 3 is 3, part is 5. So totally 5, 3, 8, 11 marks is there in this. This is A part, this is B part, this is C part, and this is D part. Totally 11 marks is there. So after that, I give the set of questions on respective sections, and afterwards you can go through the things. So the next, I want to see only the problems on this. Thank you.